Very good morning to all of you and a warm welcome to our technology meetup session on microservices. I'm sure all of you will find this session to be knowledge-packed and very much useful. I can see we have received registration from so many participants, and it is a mixed batch of number of years of experiences, more than 5 into microservices. There are some freshers who have registered with us. So I'm sure this session is going to be useful for all of you, and our speakers will make sure that there is some takeaway for all of you in this session. All of our speakers are experienced into microservices, and they will be sharing their experience, how they have utilized or how they have implemented microservices. All right. So warm welcome once again. This is our 14th meetup of Technology Meetup India. As you're aware, there's Technology Meetup India is sponsored by Entrata India. And this is the 14th technical meetup that we're having. Prior to this, we have had multiple meetup sessions, multiple virtual sessions on technical topics. Those topics were like Docker, AWS, React.js. So these were the topics that we decided based on the feedback that we received from our participants. So once this session is also done, we'll be sending you a feedback link about this session. Please feel free to voice out your genuine opinion about this entire session, as well as we'll be asking you for a feedback about the next topics that you would like to attend. So we would love to host those sessions as our next meetup topics. We've also started with Women in Technology series along with this Technology Meetup India. So we conduct interviews, we conduct sessions by women who are there in the technology. So this is for all the women specifically to encourage them to be a part of the technical field. So please spread the word across your connects about this Technology Meetup India. I'll be posting a link in the chat box soon about the meetup.com and Technology Meetup India group. Make sure to join that group if you're not a part of that Meetup India group. All right. Next few things, I would like to set few expectations. All of us have been kept on mute, so you do not have currently access to unmute yourself. If you have any questions, please feel free to use the chat box. We'll be having question and answer session at the end. So our team of experts are here to screen all your questions, and there'll be a question and answer session at the end. If you have questions in between as well, when the session is happening, please feel free to ask those questions. We'll take those questions in between as well, if possible. Now, let me move ahead with the speaker introduction for the day. So today, we have 4 speakers. We have 4 speakers for today, and this is the biggest speaker lineup for the entire event. Prior to this, we have had 1 or 2 speakers who have talked about technical topics. Today, we have 4 speakers. So let me introduce you to all these 4 speakers. The first speaker for today is Mr. Santosh Harnekar. He's the VP of Engineering in Entrata, and he's spent total 9 years in Entrata. The second speaker for the day is Eben Thomas. He's the Director of Engineering, and he spent total 13 years in Entrata. The third speaker for the day is Avinash Sangolkar. He's the Principal Engineer at Entrata, and he has spent total 9 years at Entrata. And the fourth speaker is Amiteshwar Prasad. He's also a Principal Engineer, and he's spent 12 years in the organization. So with this, I would like to welcome Santosh Harnekar on stage, and I'm sure he'll be able to take you through the next session. Thank you very much. Santosh, over to you.
Thank you, Advait. Good morning, everyone, and welcome to Entrata's first part of the series, Monolith to Microservices. I want to take a brief second to talk about diversity and women leadership. We take that to our heart, and I'm super excited to be part of this encouraging diversity in our company. So before we jump into the technical aspects of microservices, I would like to quickly talk about Entrata and what is Entrata. So Entrata is the leading operating system for multifamily communities worldwide. Now, some of you guys might be wondering, what is multifamily? In United States and European countries, housing is classified into two buckets. Single family homes, which are very similar to the independent bungalows or row houses that we see here in India. Multifamily is very similar to apartment buildings and complexes that we have here in India. So in US and European countries, these multifamily apartments and rental business is managed by professional management companies. Entrata provides end-to-end software to manage this rental business. A typical client of Entrata manages anywhere from 5,000 to 10,000 units. Our average client, mid-sized client, manages 50,000 to around 100,000 units. Some of our large clients have 5 lakh units and they are global, worldwide. Here is a little bit about Entrata and its values. Entrata likes to have fun while we do our work. We encourage our employees to speak up and collaborate on building our strategy. We believe in being excellent to each other and lead by example. So these are some of our values. A little bit about our history. We were founded in 2003. Our founder, when he was in college, noticed that the rent payments in multifamily industry was very tedious and manual. So he came up with this, innovative idea of automating the entire rent payment process, and that's how our story began. Over the years, in 2010, we grew into managing about 10,000 websites and portals for our clients. At the same time, we were processing about $1 billion in rent payments over the years. Over the years, we kept growing. We believe in open platform. So we support a lot of hundreds of vendors on our platform. In about 2014, we had our largest rent processing month. We processed more than $1 billion of rent in one single month. In 2015, Property Solutions was rebranded as Entrata, and that's how Entrata was born. We have grown over the years and built and launched new products within the platform, including accounting, which includes accounts receivable and payments and payable solutions, background screening, renters insurance, home automation, utilities, and a bunch of other products. Today, Entrata is the single largest platform under one single login that serves over 30 plus products and services for the multifamily industry. We are about 2,300 plus employees globally, and we process more than $24 billion of rent annually. So I wanted to talk a little bit about our product so that you guys have a glimpse of what we do. So within our platform, we are divided into multiple suites. And on the marketing, so we have marketing, leasing, resident, core, platform, and open APIs. So what do we do? What are these 30 plus products that we have, right? So on the marketing side, we help people find a new home where they can go to our portals and find what's available, what the pricing is. We have automated that process with chatbots and IVR systems, so someone doesn't have to manually wait for these answers. So we employ AI and machine learning for behind the scenes. On our leasing product, we automated the online application, which an applicant can submit their application, and then the background screening can score them. The background screening uses a machine learning model with random forest for building the feature analysis, and that's how we built that model as well. We are known in the industry for our screening product and other innovation in the industry. Moving on to resident management, we have accounting services, we have utility services. So hopefully that gives you a glimpse of what we have. Along with our platform, we believe in open data, and so we support open APIs to integrate with hundreds of vendors in the industry. Last year, we raised about $507 million in private investment. This was the largest private investment in Utah's history. Our financial partner, Silver Lake, is the most well-known private equity fund in the world. Some of the well-known investments that they have made are in Airbnb, Dell, Credit Karma, Jio, Alibaba, Broadcom, and many other big names. Over the years, the company has been growing, and so we are going to look at a little bit about how we have grown transactionally. So here is a quick glimpse of like what we processed on our online applications. We process about 12 million applications per month. And today we process about 17 million applications per month. Our background screening product, we process about 250,000 of transactions per month. Today we process about 1 million transactions per month. Similarly, when we look at the lease signed, we used to process about 1.75 million leases a month. Today we process a little over 3.5 million leases per month. So that's our journey. Entrata has been growing phenomenally. And with this growth, we have been evolving our architecture. And I would like to introduce Abin Thomas to talk to you about our architecture and how we have evolved and taken care of this growth.
Thanks, Santosh, for the introduction. Wow, what a phenomenal growth. Let's take a quick overview of the architecture we started with. So as you can see in the diagram, we have a single code base hosted on multiple servers, a load balancer in the front and a master database. So what you're seeing here is a classical pattern while building early stage products. You start with a small set of modules. When it is released, it's great. Everyone loves it. So success breeds opportunity as well. So in new tools, features, functionality, modules gets added. These additions in this typical classical setup extend the same code base and the application grows. Large systems like this are often called as the monolith. I think there is no. So excuse me. Sorry, right now, give me 5 minutes. Yeah, sorry for the technical glitch. So this type of setup, or I mean monolith, is easier for end-to-end testing, debugging, tracking, and monitoring, and allowed us for rapid development, in fact, helped us for our exponential growth. So while this monolith helped us in our early stages, it does come with its challenges. Let me take through some of them. First one is fragility. Since there are no strong module boundaries, each change you make to the code influences the whole stack. This means a higher blast radius for bugs. Another challenge is monolith is expensive with a higher resource footprint. Modules in monolith app doesn't exist as independent units and are closely coupled. As a result, if one module needs some additional computing, you will have to allocate more resources to the entire application. This leads to unnecessary expense and doesn't allow us to make most of our horizontal scaling. Another challenge is independent deployment. As I mentioned earlier, modules in monolith app doesn't exist as independent units. Hence, we cannot do an independent deployment of the module. So imagine you made a one-liner code change and you have to wait for a lengthy continuous integration check, which is designed for this entire application stack. Say, for example, executing unit test cases. Then your code gets merged and then it gets pushed. So this slows down this deployment, build, test cycle. Another aspect or challenge we face is technology diversity. As business grows, we need to use the right tool for the right problem. So as monolith are evolved gradually by extending the same code base, so there is a tight coupling between the initial technology as well. So due to this, you cannot just pull out one module, do some technological upgradation to that module and put it back. Another important one is this setup makes onboarding challenging. Okay, so human memory, it's limited. As and when your system grows, The inner working of the system goes beyond the understanding of the capacity of an individual. So moreover, when you hire a new engineer, even if they're handling one sub-module, now they should know the entire stack to contribute and perform. So this slows things down, inhibits progress, and lowers team morale. With that, let me introduce Avinash, who will talk about how we are addressing these growing pains.
Yeah. Thank you, Abin, for throwing lights on the challenges in monolith. So Abin just talked about the fragility, application scaling, and the resource onboarding challenges. To understand this challenge, let's walk you through one of the use case in our legendary product stack. We will look into online rental application, which just Santosh has talked. This product is used by renters or the applicants when they are searching for the new home on a rent. Just consider, Abin is looking for new home on a rent. In that case, our product will help to look available units or the home and their rent prices for specific property. Once Abin selects the house, then he can apply for it. After application, our system will screen Abin for the credit and criminal background. Once Abin's application is screened and approved, then our system will automatically generate the e-rent agreements. After that, Abin can e-sign that required documents and pay his payment online, like a rent, insurance, online fees, online application fees. Guys, it's look a very simple workflow, right? In a background, but a lot of things are happening, like the e-lease generation, then the screening of criminal plus credit background, then the payment processing, getting the unit availability as per the user requirement, notification service, like once user selects the unit, we will notify user this has been selected. Then once user does the payment, we will notify the user. All that products are coordinated with each other in the same monolith by sharing the same code base. Let's look how the code base is tightly coupled with the multiple product and domain. Let's see that in the next slide. In this diagram at the left side, you can see the products are tightly coupled. All business contexts are the mix with each other. At the first step, while moving from the monolith to the service-oriented architecture, we had started to refining monolith by loosely coupling interdependencies. After refining, you can see at the right-hand side domain boundaries clearly. So by doing that, we slowly moving from the monolith to the service-oriented architecture. Directly moving from the monolith to the microservice, it's hard. We have to take some early steps before that. Initially, we have started to move towards service-oriented architecture. While taking this early step, we have considered some good design practices that will make your transition very smooth. Let's talk about the domain-driven design. In the first step of domain-driven architecture is drafting clear service boundaries between your multiple business processes, defining domain context of your product. This step is a foundation of your microservice journey. Then comes the data modeling. This is the second pillar of your foundation. When you want to move towards the domain-driven design, you need to extract slices of attribute which are meaningful in terms of your business from the monolith data store. Then 12-factor app. It's evergreen concept. How you can design your architecture your application that will make more robust in terms of scalability. Factors like a dependency isolation, then the CI/CD, dev production parity, then the monitoring of your system is an important thing. We already implemented 50 to 60% of 12-factor app in our code base itself in a monolith. Then comes one more factor comes into the picture, design patterns. Design patterns are the problem solvers in this situation. We applied some good design pattern like adapter, repositories, then the facade, strategy, bridge, builder, decorator. We have adopted clean code concept while applying these design patterns. Then comes the hexagonal architecture. This is the collection of the good design patterns. It helps to transition between the monolith to the service-oriented architecture. We will deep dive it in the next couple of slides, how hexagonal architecture looks, how you can design, what are the components. So let's look at the hexagonal architecture in a detail. We have implemented this pattern to divide our system into loosely coupled interchangeable components. Hexagonal architecture consists of 5 main components. First one is transport layer. This will trigger your interactors like a business logic required to run your business. Some example of transport layer can be the HTTP request, might be the controller from your application, or the cron job, or any event pipeline. Then comes in a picture interactor or the business object. These are the heart of hexagonal architecture. These classes performs the business logic and applies business rule required for your business process. Interactors. In interactors, we have encapsulated the business logic and rules required for our business domain. This is the core of our architecture. Then the entities come into the picture. These are the simple domain objects. It's just the data structure with the data setup. They won't be knowing. They won't need to know about where they store, how they are stored. Then repository pattern comes into picture. Repository pattern actually draft the bridge between entities and the interactors or the business object. These are the just interfaces that will get data from data store to instantiate the entities or load the data for the entities. By using the repository pattern, you can do all CRUD operations required for your business. Then the data source. These are just adapters of different data storage schemes like RDBMS, REST API, CSV, NoSQL. By applying this data source pattern, you can easily interchange your data sources from the RDBMS to the REST or the plain CSV or NoSQL as per the scenarios or the candidate of data store. Then let's look. In this diagram, you can see how we have implemented this hexagonal architecture in an online rental application domain. You can see clear service boundaries between our domain and other product domain. That has been clearly drafted in this diagram. So all foundation work has been done. What to do? From that, we already placed a good service-oriented architecture. But before applying that new service, we need to ensure code meets the quality standards and meets the reliability of business logic. Application with the clear service boundaries is our testing strategy. Defining good testing strategy will save your future time and money and bring the confidence on the newly developed services. It will help to catch the early bugs, early damages for new services. In an initial step, we are focused on testing our interactors. where our core business logic lives. This will help to test the business logic in a detail with all scenarios. When you start writing a test cases, it will force you to apply some good design principles and patterns with your code base. While writing a test cases, we need to consider the CRAP score. CRAP score is abbreviation of change risk anti-pattern. It shows the index of complexity in your code base. Whether your code base is growing very complex, you are adding too much conditions into that, it will catch up in a CRAP score. If you able to achieve lower CRAP score, it means you are simplifying code base, because writing a code which understandable by the computer is an easy process, but writing a code which can be understandable by the other human being is a good practice, and it is a sign of good development. Once we have achieved the 100% code coverage for our interactors, then we can start on the integration testing. You can test your data sources, transpose layer. By doing that, you can check whether all service boundaries are clearly drafted and whether that components are clearly integrated with your business logic or not before deploying to the production environment. So that's it for the unit testing strategy. Let's check what is next. So once all foundation work done, architecture in place, unit testing strategy in place, question arises how you can apply the new services in your code base, because you need to have the user acceptance testing before deploying it to the all clients or the all users, right? For that, some of the good strategies are there, but we are using two main strategies to apply new service into the monolith directly by using the vertical slice. Vertical slice is process of finding the business workflow that you can make the independent. You can isolate some of the business processes by uplifting all required components for your service architecture. You can uplift function as a service. By doing this, you can slowly migrate from the service-oriented architecture to the microservice. In our case, or in our online rental application, we can slice out some of the services like screening services. We can easily slice out. Then payment processing services, document processing services, we can easily slice out. So vertical slicing is done for some of the components, how to apply. Then feature flags come into the picture. Feature flags are the condition implementation of old versus new functionality or the services. Conditionally, you can release some of the new services for the target users. Once you have done with user acceptance testing, then you can roll out that new service for all your users. That's our exciting journey from where we heading from the monolith to the service-oriented architecture. Join me welcoming Amiteshwar Prasad, who will take you through journey of slicing service-oriented architecture into the microservices. Please welcome Amiteshwar Prasad.
Thanks, man. So that was a great research and core knowledge shared by Avinash. It helped us to make our monolith into service-oriented architecture for one of our products. So let's dive into this one. So before going there, let me give a little brief on our awesome product, which is Resident Ensure. So it's an e-commerce platform to sell renters insurance to residents. It's an application which is using completely service-oriented architecture. You can go through some of the screenshots over here. These are the portal's screenshots where a person can log in, can go for their dashboard, they can view the insurance and the policies which they have to pay, the insurance premium over there. So this entire thing is built as like the front end built with the React.js. The backend is using Slim API framework, and is tightly bounded with our application, which is RDBMS open source Postgres databases. Our entire backend is 100% unit testable, and we are using Swagger to document our APIs. So Swagger is an application where we, as a developer, as a QA, both can use our entire documentation to see what data we have to pass, what are the responses come from that web service, and at the same time we have both of the things. Even it fails, what we get, even it's going to be a success, what we'll get. Going ahead, so this is our monolith architecture. You have already seen it there, right? So this structure is having to split in our application in service oriented architecture as well, which can be a service zero, or it's the first step to move in a bigger world. So this step is only pain area to build up from our monolith to service oriented architecture, as the application consisting of your as well as our product are tightly bounded and even coupled with each other. So when you try to break it, you have some dependency to isolate it to make a new or single oriented application. So you can see this is our current state. Now we are fully isolated with our code set. Only required for our domain need is not a single dependency is here. So entire library, the products, and then application. These what we have is only needed for our application. It's totally deployable, easily scalable as per your need or your requirement, upscaling or downscaling. So this you can see in our application. This flow extends our section how we describe our product. It is hosted on a web application and easily scalable server, which is well documented with our Swagger thing, and we are using queues and caching mechanism to support all the data putting in backend, and it is already supported with our RDBMS, our Postgres database, and we have a logging mechanism as well. So one of the thing before going to our application, I want to share one problem statement with our application. We already have our application in our system or service oriented architecture, right? It's already isolated from a big monolith to a small monolith. It's still a monolith. We have some of the problem statement we got over there. So our application is running very smoothly, right? And easily scalable too on our server. Code model is heavy used and is the heart of our application. So let me just give you a brief about what is code. It helps us to pull quotation on policy for residents, which costs them how much premium they have to pay and what are the tenures over there. So considering the scenario, or our portal is open and anyone without any login can query with it, right? So we don't have to go and log in to get a quotation for our requirement. You can go to the website, just feed your data and you can get the quotation. So say out of 1000, we are getting almost 40 to 50% of our customers really going to our entire life cycle to process it and get it from our. So which is the real share, right? We are not going to go on a site, you are not going on a Flipkart or Amazon and getting the data at the same time. You have to compare, right? You are comparing with two different stores, two different online applications. Which one is giving you more benefit? So once you get, and we get the services loaded over there, we need a rapid way to test and deploy code formats, right? For A/B testing, since it's a pass on monolith, we can't able to scale it all alone, because scaling on that single application, we have to build our entire resource, which is a big one. So you can see we are talking about something which we need to discuss, and that is code. And why don't we require code to move to a code service? So which will help our infrastructure to scale only in the business resource as well as the entire application as well. So the thing we are talking about is a complete microservices. Okay, so what is a microservice? It's a small application developed, teams create independently. So if we are talking about our service application, which is already built in a monolith, so why we are going with a microservice? What the main advantages we are getting using this microservice? So we have some of the aspects which is written, you can go through the slide. Let me go with it. The agility. So independent team can get their issues fixed more quickly. So anybody who's working on any of the issues, they can fix it and push it on the live server with our proper code execution with the unit tests or whatever the things you have in the backend. It's easily scalable. Each service can be independent, we scale as per need. So if we have different microservices built in different aspects, we can scale one by one. We don't have to scale all at once. Which one is needed, scale that one only. Scale up or scale down. It an easy deployment cycle. So we have internal CI/CD pipelines. Like we can use external tool as well. Like we have GitHub Actions, we have Jenkins pipelines, and other stuff. We can move it to deployment of a code on a live server. So it is the only tool where you can automate your process for pushing your code from your entire application on your node development to a live one. The most important thing I want to build here is we don't have any tech boundaries for generating any of the microservices. So one microservice is built in your own stack, another is built on the own stack. It is totally different stack and build, and that requires a better candidate to be used, right? It's not like the current stack is ongoing, so we have to build in this one. Whatever your business requirement is there, then you have to build on that language only. It's a complete usable thing. Once code is written, you can be used by other applications. Even if you see, we have one application given by Avinash. He was saying Aben is going to rent some apartment to live in there. So there were some of the processes we were showing over there. The profiles is there, right? So profile consists of the name, the street address, the email address, the phone numbers. So we are storing another application and we are pulling it from there. At the same time, when you are going to payment section, we still need at that time, what are the profile details for that person? We don't have to query again, right? We don't have to write the code again and get the data from our database. So we can use that alone code, which is already written, or you can use a microservice to call the data and show it over there. So here you can see a microservice can talk to another microservice as well. And the last we can decide is the resilience. So service failure can be degraded, right? The performance. Service can be degraded the performance, but the application is not going to crash, right? The service is not going to crash the entire application. You see the application we are talking about, the profiling is coming on the right top. Say it's a photograph over there, the name is there, and the service stuff is there. So those things can be broken, but the entire application is going to execute, right? The only section on the right top can be isolated, it's not working. So now the thing which we have already discussed and previously detailed by Avinash, we're talking about a thing which is called vertical slicing. So vertical slicing is already, since we have already isolated our application to service-oriented architecture, so making it a microservice is just slicing the entire application vertically, right? So take what you require for your API, then what you need for your library, and all corresponding data for your data set. Then you have your assure in vertical slicing what you need for that service. You can see in a simple language, like it's like a multi-layered cake, and a slicing is enough to give a kid and enjoy. That's what he needed, right? He's not going to give an entire cake. He just needs a slice over there. So this only needs to build a microservice. We have just discussed the stack to use to initiate the request from our server, right? But there can be things we need to think about the data set. In slicing, we already discussed that there are microservices will be having its own library, their own code set, and most importantly, the data set. So there can be scenarios we already heard, like a monolith can be a single database. Two different monoliths can communicate with the same database. So we have a scenario, and in this section as well, in the microservices. So two microservices can have a shared database as well. And since one database is getting loaded, or it's getting too much of load, it can affect both of the microservices at the same time, right? So in our current scenario, we are going to discuss about only a database which is dedicated to a microservice. So how we decide what are the scenarios over there? For these different scenarios, we can understand with a concept called a cap theorem. So you can see the circles rounded over there on the right side, right? So it is nothing much in the vast world. If you see, it's an abbreviation of three common words, like it's a consistency, then availability, and then a fault tolerance. So how we decide on the basis of these three things? So just consider this example. We can have a catalog type of web service with a NoSQL document database. Say it's like a CosDB, because we just need to show a set of lists pre-stored with no mapping, because we don't have to rerun or get the data at the runtime. The catalog is already predefined and stored in somewhere. We have to just show to the customers. And again, if we go for a card service, a card service can be built again with a NoSQL database, but it requires a key value pair, because there are something which need to be mapped, like MongoDB. We have some relevance of products and quality to the store, and past look how inventory we have to update it, right? So we have something dependency with the references over there. And finally, when we are going to an e-commerce site, we have an ordering thing. So an ordering needs an RDBMS database, like an PostgreSQL we talked about. So it needs a transaction. It deals with a very critical scenarios too. It stores too much of the data. We have to generate the invoices. We have to have data in a persistent way. So we need to have a database that is going to be an RDBMS type of things. So how we decided, like what are the things we have selected from this screens to implement for a database. So say for the catalog thing. So catalog thing does not require for going for every time working. We consider an A and P, the combination of A and P, the availability and the partition tolerance. And again, when we are talking about the card services, that is requires to be a NoSQL database. We are considering with the two concepts, the consistency and the fault tolerance, right? And the term when we are trying to have a RDBMS database type, so we are considering two scenarios: the consistency and the availability, because that requires to be very much accurate in time, and we can't mess up with the money thing, right? So we are using in the section of C and P. So our application has multiple microservices, right? So which communicate internally too. Our code service is one of that many to give an idea how it works. A client initiate the request from the web. So you can see just a small example. We can show how the microservice is working internally between an aggregator pattern. So a client initiate the request from the web. It lands to the CloudFront setup, which is already loaded with all of the static contents over there. And it returns a call to our API services or the microservices, which is horizontally scalable. Whatever the request is coming over there, we can scale it horizontally as per our load. Backend is already supported with a database and is clustered. So if you see the database by default, we were having some example in the back, right? We were talking about the cap theorem. So for our condition, the example which you are showing, we were using an A and P, the availability and the partition tolerance. We are not thinking about consistency right now, because we are going to have our own service to sync the data across the database inside our cluster using Kafka. So we are using Kafka for just syncing all the data from databases, which is linked with this our microservices. One of the biggest hurdle we have to deal with in a development and deployment is tracing the bug, right? You have done the code, you have deployed the code, but if anything is going to broken over there, you have to come back to fix it. So a centralized build application like our monolith is simple to debug, right? We are using a debugger tool, just log tells us which file, which line, and which type of data is broken. Just go and fix it and deploy it. It is working all fine. But in microservices, it is meant to be distributed one, right? It is a little bit a harder thing to get a backtrace. Like when it fails, we need to know like which service has failed. And even if it's failed, which service generated this log. So to overcome this problem, we need to have a centralized logging services with a proper tagging of the services and the server. Like when the error is generated, we need to know it is coming from this very server. Maybe it's down, maybe it has some lagging, maybe the network latency is there. So such of the cases, we need to have a proper logging. If you can see, like we have the Elastic servers as well, we can have too much of log at the same places, but we can't go and just dive into it and get that log, right? What we need to search for that one. We need to search, and from that big sea, you have to get one single log, which one is broken to fix this system. So we need some of the Elasticsearch type of the things over there, such that we can search easily and fix our code faster. For such a case, we rely on cloud watches and even some of the event caching services as well. And some of the tools, external tools, like we have a Fluentd application running on your container, running on your virtual machine, which can directly communicate with the New Relics, the Papertrail, the Kibana, where you can want to store the logs over there. So one other thing we would like to mention in here, each application can be designed as per our business loop. So it can happen that a framework smoothly working for our blogging site may not fit for our backend banking domain application, right? They have something different of transaction based. We have blogging for showing the data over there. So it can't be happen like the entire system we have built for a blogging site is very much applicable or feasible for our banking domain. So our application and the R&D we have done is totally our domain driven design, which is a very good thing for our entire big application. It comes with our older experience with our product. Since we have a proper domain knowledge, even our business domain knowledge, how we have to scale it, how we have to break it, split it, and make it working. So the steps which we have from monolith to service oriented architecture and then service oriented architecture to a microservice. That can be a simple path we have to become in a microservices. We can't go directly from a monolith to a microservice. It will break your mission, and you have too much of the resource to be used over there. So that's from our end. So Advait, over to you.
Great. So thank you to all the speakers, and I'm sure all of you will agree with me on this, that this session was actually with full of knowledge and it was informative. So now we open for question and answers. So if you have any questions about this entire session, please feel free to ask those questions in the chat box. We have our team who will be answering those questions. So yes, do we have any questions yet?
First question is from the Rushi Masurkar. Very common scenario where we think about breaking a shared database to database per service. How do you maintain relation if they are any? It's common question of microservices. How, because we will be designing our data attributes like a domain driven design. Just we talk about the model. So for that, we can use the data pipeline to coordinating between the multiple services. Like we can use the Kafka, RabbitMQ to maintain that relationship. Is it good to move any product to microservices? If not, then what are quick checks that I should consider to decide is my project good candidate to use the microservices?
Great question, Jalinder. Love the question. So you always want to be very clear about your business objectives, right? If you already have a good website that is scalable and it's working fine, you want to understand like why do you want to move to microservices? So one of the direction that a lot of technology companies are moving towards is they are moving into cloud, right? And cloud inherently provides that elasticity where you can create simple components that can scale. I see there was another question that was asked, how do you go from X million to maybe 10 million, right? Like, so that is the basic tenet of microservice. You create an independent component that can scale on its own. And not only that provides the ability to rapidly develop because it reduces the blast radius, right? So we talked about the code service, like why did we choose the code service as a candidate for microservice? It's because we have a very spiky volume during our busy leasing season where we see thousands and sometimes hundreds of thousands of users coming to sign up for an insurance policy. And so those will be the candidates that you want to look for, where you are building this microservices on the cloud platform where it is elastic and can scale as and when needed, when not needed, the compute resources can slow down or go down, right? So that would be a good candidate for microservice. Hopefully that answered your
Yeah,
question.
because all time your business will drive that decision, which part of your business processes you need to move for the microservices, right? Because that requires some cost, some uh, expertise to move to the microservices. So that's totally business need and how you are growing and whether you need to scale out or scale down on some of the services. Have we used NoSQL databases and the tools which are mentioned in the slide? Amitesh, you can
Yeah,
answer
Mohan.
that.
We are using NoSQL database. We are using CouchDB for the document type databases, and the tools which we have used for like Habana and Kafka we are using for logging those things. And much more thing if we already are using different caching mechanism for Redis, so that is also in our queue. Hope this answers the question.
Mukeshwar asked how to handle transaction between a service and fallback mechanism.
So when you're talking about the transaction using a microservices, if you're handling a single layer, we can have a proper database transaction. Else we can go for a different asynchronous transaction or a Saga architecture where it goes from multiple layers and commits the transaction over there.
Let me add a little bit around the transactions question. So one of the basic tenets of microservice is resiliency, right? So when we plan for transactions in microservices, you have to plan for eventual consistency. So what that means, your application, your independent microservice should be okay to not have that transaction completed right away, right? So you have to design your application like that, but you're okay with that eventual consistency. So there will be messaging and other mechanism built to finally complete that transaction.
Thanks, Santosh. So there is another one is the cons with the microservice architecture. So cons, you have already seen, like we have the logging thing. So log requires to be distributed. You have to go and search for that thing. And before going or diving to your microservice, you need to first plan it. You can't go a rollback with a microservice back to again the monolith one. And at the same time, if you're talking about the functional thing from the company perspective, it costs you too much because you have to scale at the runtime. When it's there is a load over there, it won't ask you. It will scale.
Yeah, correct. One more question about the scaling. How you can scale from thousands of users to say 1 billion? That is a great question. So for that, you can use the containerized system. You can containerize your application and you can auto scale that.
Yeah, you can use the like Kubernetes and the pods over there.
Yeah.
So pods are auto scaled over there. You can have a minimum counts like 2, 3, or 5, 10. And once the users is increasing, it will auto scale to 1,000,
Yeah.
10,000, whatever required.
But one major aspect is there, you need to consider the load testing on your application before that, because that testing matrix will be important part of that, how your application will behave in that scenario, how you can define the boundaries of each microservice. Avinash M. This is the business process. So your products has to coordinate to define the business boundaries. Your product owners and your software engineering team has to collaborate. That is a total collaborative effort to define the business boundaries and business processes throughout the multiple teams.
Yeah, means just don't add everything on that microservice. It will
Yeah.
again going to like a workload over there. The microservice
Yeah.
requires to be like less requirement to be done as fast it can finish. That is
Yeah,
best.
lightweight. It should be lightweight.
So there is one question about, is there any good resources for, microservices? Yeah, the articles by Martin Fowler is great, as well as there is a great book in Amazon. We will, send that link. So it's Monolith to Microservices, Evolutionary Patterns to Transform Your Monolith by Sam Newman. So it's a great book.
Yeah, you can read the Netflix story as well on the Google.
Netflix, they have their own blog as well.
Yeah.
For the Netflix blog. So Yogesh is asking how can we scale the database for million of data and almost zero downtime? So scaling is like creating the cluster. You have a multiple starts over there to create the different application. And you can do have a partition to call the data at the same time using your microservice or anything. But you are going for a zero downtime, like it's not technically possible. Like you can have a zero downtime. You must have to slow down some of the process, and you have to some of the pods which is going to respond on the older one, and then you have got to the new one to breaking it.
It's orchestration of
Yeah, it's a
old
complete
versus new.
orchestration.
Omkar Gaurav, when using the microservice architecture, if we have some common code in multiple services, like maybe custom DB drivers, encryption, etc. When we change the common code, we need to redeploy all services. So what should be the ideal structure for the same?
It's not required to deploy when everything. It totally depends on your contracts. Like what are the contracts between your previous microservice to your current one? If you're changing the entire parameter, like say earlier the function was taking integer as an input and afterwards taking a string as an output. So it can be broken over there. It's totally depends like how we have a contract between those things. So making the changes, this is the most beautiful thing of the microservice. When you change your single microservice, you have to deploy that only. You don't have to deploy everything until there is a broken contracts over there.
So contracts plays very important role at the foundation when we design the microservice architecture.
Yeah.
There is another question. When I am starting to build a new product, users are going to increase over the time, and why should we start with microservices from the beginning itself?
Yeah, that's great.
It's a great question. It's a great use case, depend on the business. So microservices for a startup usually will be an overkill.
Yeah.
Typically, how products evolve is like that they start with one or two set of modules, get some acceptance, then evolve.
Yeah.
So yeah, it depends on business needs.
It's totally business and financial. How you are growing in a financial terms, that will drive the decision towards the microservices.
This is actually an ongoing debate. If you guys go to martinfowler.com, there is actually a very good article where Martin Fowler and another well-known architect goes back and forth on what should you start with. One advice that we will give, definitely, whether you start or not start with the microservice, make sure that you are creating a modular structure, because at some point you are going to scale. So keep that microservices mindset when you begin itself. Don't wait for too long. Otherwise it becomes like another exercise of starting to break your domain. So very early in the stage itself, clearly identify your domain boundaries and make sure you're structured that way. So when you need to scale independently, you're ready to do that through microservices.
Yeah. Starting with the service oriented architecture in that case is good approach, I think.
I would agree with that.
Yeah.
Maha is asking for how the security layers handle to each microservice applications. So we have multiple layers of application in communicating with, like OAuth is there, then token is there, OAuth is there, and token is there. We can have proper intercommunication between with a proper token over there, and the validation we can use with the OAuth application as well. And if we want, we can have a proper microservice which is going to communicate internally. They are not going to be exposed externally. So we have our AWS or subnet or VPC, which you can decide it won't be accessible from outside.
Okay. When one should prefer the microservices with API gateway as a mediator, or with microservices with BFF model. So should we prefer microservices with API gateway or with BFF model?
It's actually repetitive questions. Santosh,
yeah, I think it depends. So it depends on the use case, right? If it's a primarily backend API, you will go with the API gateway. For the backend or frontend, I think Avinash kind of touched that when we talked about the hexagonal architecture, right? So when you're building your backend, you want to make sure that it is, and your frontend, both are independent of each other, right? And so hexagonal architecture is a good way to look at like that use case of how you use hexagonal architecture to decouple your front end from your back end. And even like your middle tier from your data layer as well.
Yeah, adapter layer plays a good role in that. Placing adapter layer between your business logic and the data sources is a good thing.
Yeah, I think I see a pattern of a lot of people asking about common code, common services, right? So there have been like quite a few examples around microservices that will take an image and then create a small thumbnail, right? So I'm seeing some questions around encryptions or utility or like certain code. I think what you have to decide is, is this component like what's the nature of its use, right? Do you need to scale it? Make it reusable? Can you componentize it into a container and deploy independently, right? Those are some of the aspects that you have to look at. So encryption could be a good use case where you have lots of hundreds of documents that you need to encrypt, right? Similarly, I think someone asked about security. I think that's a perfectly good use case for a microservice, because you do not want every applicant to build that authentication and authorization in each individual application, right? So you want to make sure like you use a microservice that takes care of that need. So again, carve out independent areas that are more of services like authentication or encryptions. As far as the business functions, go by like what Avinash had covered earlier on the domain driven, right? Make sure like you're very clear about the use case of your microservice. Yeah, so when it comes to backend language, we primarily use PHP, but we have been, on the front end, we use React. And it's not just about the backend language, right? We employ machine learning, data science. And so there are plenty other use cases that we have, different tech stacks like Redshift that we are looking at for our data and ETL processes, Snowflake and Domo for our reporting. As far as the languages are concerned, we are currently using Node.js in some pockets. We use PHP. We have used .NET in the past for integration. So hopefully that answers the questions. But again, with this evolution, with this journey that we have taken, we are open to looking at technology that best fits the problem, right? And that's the whole goal about moving to microservices, because it's going to enable us to use the right solutions.
In addition to Santosh words, like we have our application, which like something we have done for the Kubernetes, we are using PHP over there, such that we can easily scale it. And sometimes we have some services which requires it to invoke for a few of seconds. I don't require to opt for every time. So for Node.js, and we are using Lambda functions to invoke those things.
So moving to microservices will need much time, but the new business requirement are in backlog. How to handle this? Should we stop new development? No, that's a slide in Avinash covered. Like how to slice an existing monolith.
Yeah, slowly you can move by just taking vertical slices and applying that vertical slices by using the feature flags. Then you can do the user acceptance testing for the sum of the target users, and you can roll out that new service, right?
I love that question, by the way, because I think as products grow and business requirements grow, and as we add more customers, that is always a challenge, right? And for the technical and technology leaders, we have to keep an eye on how we are building our products. So it is a very important aspect of how we build products here at Entrata, where we make sure, like as we are building new components or as we are addressing our technical debt, we're carving out areas like what Avinash mentioned, right? Like take use like a particular area or a use case that makes perfect sense to carve that out into either new technology or even like laying the foundations of moving towards microservices, right? So again, it has already been covered. Like it's not a jump directly to microservices. You have to do some foundational
in
work.
some cases you can jump to directly microservices, but in that case you have to already draft the service boundaries between your domains. If that is not clear, then you need to go to the service oriented architecture first by drafting that service that service boundaries very clearly.
Yeah, so one question is, do microservices result in more code replication? It's actually the opposite. It's you carve out a specific function and build a microservice around it, right? So that specializes and it can scale and handle the volume for that specific function. So it actually is the reverse of code replication. Now, there is some replication of data that happens, and that's because of the context that the microservice is working on, and that's fine. I think today with the cost of storage, that's not really a primary concern. I think the primary focus should be how rapidly can we build our products and deploy them, and then how can we scale them independently, right? And so from that perspective, there is some data not replication, but duplication for sure. But as far as the code is concerned, absolutely not. It's actually the opposite. So there is a question about strangler pattern. I'm going to try to answer it to the best of my knowledge here. So strangler pattern is basically migrating from old way of doing it to the new way of doing it, right? And so it's similar to using feature flag, where you want to figure out a way to scale certain aspect, or I guess migrate to the newer aspect by using the feature flag. I think that's a great strategy. We have done something similar in the past in some of our products, where we had a specific version and we kind of started deprecating old while we started introducing new. And I think feature flags is a good way of doing that.
Yeah, I mean, it's microservices is lightweight. That doesn't mean that we cannot apply it for complex and dependent products. The online application is a complex and dependent product. We have to have a strategy for it. So we have to find out the dependencies, the boundaries, have this hexagonal architecture in place, do vertical slicing, slowly migrate.
In that aspect, one more thing. Which services you gonna have the synchronous versus asynchronous? You need to identify that in complex scenarios.
Someone is praising our office space. Yeah, we have a huge space. Someone is praising our office space. Yes, we have a huge space here in Pune, in Tower 9 and Tower 8. Again, most of you guys know we are a global company. Please look up for our office building in Salt Lake City. We have a huge space there as well.
From Ravi, how you planning for migrating from monolith to microservices, whether it's rewriting everything from scratch, and what are the challenges to migrate the DB?
Yeah, it totally depends. Like if your structure is already been built with a proper hierarchy of MVC, you can you can use that older code as well. If you want to use a new stack, you have to rewrite the code. But again, you can't go from monolith to directly a microservice. We need to have a service-oriented architecture first. First, you decide like the boundaries, as he said. Once you're done with those things, if you require a new code set to write over there, or you can use your older code as well.
It's totally dependent on how big your monolith is and how structured.
Yeah.
Right?
And at the same time, the database is required as per your need. If your microservice is having a dedicated databases, so you have the only tables which required for that microservice. So you have to split it and use only those tables and migrate it from your older database to this new database.
Not only table, only attributes that make sense for that microservice domain. That is important part, right? You will be having some redundancy of data by doing that, but that is okay in terms of microservice.
Yeah. And just one thing, I like where Avinash was going with this, right? Like you carved out that data, and it doesn't mean your monolith doesn't exist, right? As you start taking or carving out some vertical slices, your monolith will still exist. And that's where we will use messaging buses like Kafka or RabbitMQ, depending upon the use case, where certain elements of data will get synced up using PubSub model. So that's a good way to start thinking about how you're going to split your database and make sure the data that is relevant for your microservice is going to be still available.
For some period, you need to do the parallel update by using the data pipeline. Like in a new database, also it's monolith database for some of the attributes.
Another comment. Thanks for the session. Looking forward for next section. Definitely, yes. This is a series 1. So we'll be taking you through a journey as and when it progresses. I will repeat the question. Is it always necessary to use user domain-driven design or domain-driven design? Given the domain has simple business logic and just requires pretty basic CRUD operations, would domain-driven design design will be a overkill.
Yeah, that's correct. In some cases, your actually how your business is complex and how your domain is doing complex things, that decides whether you require to carve out the service boundaries between the multiple business process or not. That's totally engineering decision and product decision in some cases.
All right. So thank you so much, all of you, for this wonderful session. And thanks to all of you who have joined. And we look forward to seeing you once again for the next sessions. As Abin rightly said, this was the first session of this series. And we keep on having these meetups regularly on a quarterly basis or on a monthly basis. So do join that technology meetup group. The link I've already shared. We'll also be sharing that on our social media. So thank you very much once again for joining this session, and have a happy weekend, all of you. Thank you.